Hello, quantum explorers.
And awesome robot makers. Welcome back to the Quantum Kid. I am Kai, the Quantum Kid.
Hi, I'm Katya, science communicator and theoretical physicist. And indeed, we will be talking about robots today. And you might think, at first glance, robots and quantum computers, not much in common probably. But it will be a very cool discussion with two of our guests. Right, Kai?
Yes, but before that, can I please see a real robot?
Where would you see a real robot, Kai?
In the nearby robot lab in Zurich. That's called ANYbotics. Oh, right here. What? Oh, it's a Christmas hat because of Christmas magic. Luckily, I didn't go to Mars like last time. And what is this robot's dog thingy?
Hello, welcome to ANYbotics. I'm Ayla. I'm a mechanical engineer here working in mechatronics department. This is our lovely robot ANYmal. It's an inspection robot. It basically goes into dangerous places that's hard for human to go in autonomous way and faster, and it just reports you back with its all sensors that it has.
Is that a LiDAR?
Yes, it is a LiDAR. Good catch. It always scans the environment and creates some cloud dots, let's say, and matches it with what map it has and understands where it is in the whole room, so it can locate itself. It can go to areas that are dangerous, maybe some radioactivity is there, so you don't want to send humans there, so you send a robot. Or if there's a natural disaster, you can also send this robot to inspect the area, and with the thermal camera you can see whether there are some living beings under the collapsed buildings, for example. Most of the use cases is for industrial inspection operations. Basically, this robot can go to an offshore platform, which is just in the middle of the ocean, and it's very expensive and hard for humans to go there regularly.
So what happens if the robot gets stuck? Can they ask a quantum computer, oh, I need help, my foot is stuck, how should I wiggle it out?
A quantum computer will be, of course, more faster and would give a response much faster than the computers that are on board. So maybe you're right, with the enough information that the robot sends to a quantum computer that is located somewhere else, can solve many different scenarios in a very short amount of time and select the one that would fit the situation the best and send it back to the robot so that robot can maneuver itself out.
So in the future, can these robots think like humans?
Thinking like human includes so many different things altogether, right? We have emotions, we have all understanding, the reasoning, why we are doing this, why we are doing it in the way that we are doing, and what are our environment. This is all a data that a robot needs to sense and understand and compute and give a response to. I'm not sure about the emotion part, whether robots will ever have the sense of it, but I think with all the data that we have right now and with the quantum computing in the future, robots can reach to a point that we might have questions of what is the difference between robots and humans.
The time is ticking and I need to go.
You seem very busy, so thanks for your visit and see you at some point.
Bye. Oh, I'm back.
Welcome back. So, how was it?
It was so cool, and the robot dog was so cute. But wait, I still got the Christmas hats on.
Great. So, Kai, we're going to be talking a lot about robotics today and quantum computers. And we have two amazing guests joining us, and they are
John and Ken.
Correct. Yes, we've got John Preskill joining us today, American theoretical physicist at Caltech and the director of the Institute for Quantum Information and Matter, who actually coined the term quantum supremacy. Welcome, John.
Good to see you, Katya and Kai.
And we also have with us today robotics expert Ken Goldberg, who leads a robotics research lab at UC Berkeley, and actually, among many other things, is looking into how humans and robots can learn to collaborate. Welcome, Ken.
Thank you. It's nice to be here with you guys and with John.
Hi, Ken.
Kai here just came back from a robotic lab here in Zurich. What did you see, Kai?
Well, I saw a robot dog, which was really cute.
So the researcher told Kai that in the future, robots could ask quantum computers for help. So we wanted to talk to you guys about that. So this emerging field of cloud robotics Ken, maybe you can kick it off and tell us a little bit more of what's happening in that field and how realistic it is that robots could ask quantum computers for help if they're stuck.
Well, you're really thinking about the future, I have to say. I appreciate that. This is going to be Kai's generation, right? He's going to figure out the next class of robots and computers that are out there. I will tell you, one of the challenges is that right now there's a lot of excitement around robots and humanoids. And I'm a little concerned, many of us in the field are concerned, that the enthusiasm is a little ahead of the reality. So we believe we're going to make huge progress, but it may not happen as quickly as being predicted. And the challenge is that robots still have to deal with uncertainty. They have uncertainty that arises fundamentally from three sources. One is in the perception, because they can't perceive the three-dimensional world in great detail. That's still an open question, how to build a three-dimensional model of the world in front of you. We don't know how to do that. Number two is in control, namely that if we tell the robot to go to a certain point in space, it doesn't always exactly get there, and that's because of small errors in the motors and the gears that are very, very fundamental, very hard to fix. And the third one is in uncertainty in the physics. And I'll be very curious about John's perspective on this because he knows a lot more about this than I do. But there's fundamental uncertainty that comes out of friction. And we don't know how to model the very minute friction and deformations that happen during manipulation. That is very subtle and very, very nuanced. So humans are able to do this. Animals do it too. But we still don't know how to get robots to do it.
Yeah, John, would love to hear your view on that. Maybe you could start by explaining uncertainty a little bit in quantum, just to give us some context.
Well, we all deal with uncertainty in our daily lives all the time. We're never quite sure about anything, but some things we can predict pretty well, and we're nearly certain, and other things we don't know. So every time I look at my hand, say, I'm pretty sure I'm going to see 5 fingers, and sure enough, it worked. And from experience, I know that's the case, and it's a pretty safe prediction. But say I'm watching a football game and somebody's coming down the field and taking a shot on goal. In principle, if I knew everything, if I knew exactly where the ball is and exactly how the player's kicking it and exactly what the goalie's doing, I could say it's going to be a goal or it's not going to be a goal. Of course, the reason the game is fun to watch is we don't have all that information. So we can't be certain what's going to happen. We can only say, oh, or there's a 1% probability this is going to be a goal based on what we know. Now, I'm a quantum physicist. We think about uncertainty in another way, a kind of uncertainty that is unavoidable even if you know everything. In quantum physics, even if you know everything, sometimes you can't predict what's going to happen. So say, Kai, suppose I flip a coin. Okay, it lands on the table, but somebody covers it up right away. So I don't know which side is going to face up, whether it's a heads or a tails. And now I ask you to guess, what's it going to be when I uncover it? So what would you say? How would you make a guess?
In between in a quantum state.
Oh, all right. Well, you're already way ahead of me because you're thinking about a quantum coin, that's where I was going next. But if it's really quantum, and usually it's not a coin, then it's something like a single particle, like, an electron, a little particle, say. And we've arranged it's either over here or it's over there. And now you're going to look to see where the electron is. And in this case, even if you knew everything about the way that electron had been prepared, you'd be helpless to predict, even with all the information that it's possible to have, where that electron is going to be. So it's a different kind of uncertainty than I think Ken was talking about. It's uncertainty because even if we know everything, we can't predict. Usually when we talk about uncertainty, it's because we don't know everything.
So how certain are you that it's going to rain tomorrow, for example?
Can I see the weather forecast? It's basically just looking at clouds where they could potentially go.
Because if you knew everything about those clouds and everything about the atmosphere and how the wind's going, then maybe you'd be able to predict with very high confidence that it's going to rain tomorrow or it's not going to rain tomorrow. But nevertheless, when you look up the weather report, it might say 50% chance of rain because we just don't know all those things.
I think as John's getting at, there's different categories of uncertainty. I have a question for you, Kai. When I was about your age, I was very excited about robots also. And I'm curious, what would you like a robot to do for you?
What I would like it to do is, first of all, not allow it at all to get full control. Second, if I am in my room, I'm playing games, and then my mum would come and then say, Kai, can you please clean your room? I'll say, Robot, can you clean my room? And it'll just answer, okay, beep, 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 picking up stuff, lowering stuff.
Good, good. That's pretty much what I wanted too. So the robot will do all your chores, and then you could keep doing whatever you want. Reading about quantum physics, for example, right? I get it. Absolutely. Now, if you think about it, there's a lot of things that are very difficult about even that. So if you want to pick up little things or complex things in the environment, like let's say you've spilled a little bit of, I don't know, salt on the floor somewhere, and you want to pick that up, right? That's actually very subtle. How do you get that? You have to go figure out a strategy, and then you have to perceive where the salt is. You have to manipulate maybe a dustbin, a brush, all of those things. Right now, all of that is very, very difficult for robots. So we're not able to get there. And it is a fundamental question of computation, but also these fundamental limitations of our understanding of how to use the computation to be able to get a robot to do it. So one of the ideas that I'm also very excited about is that quantum physics will lead to quantum computing, and somewhere down the road we can accelerate computation enormously. Now, I don't think, and John, I'm going to ask you about if you believe it'll be possible to have a quantum computer in the robot itself, or if it will be in some data center somewhere, and that the robot could possibly use a version of the internet, some network, to access the computing that might be very far away. And this is what we call cloud computing. So, John, I'm just curious what your thoughts are on practical applications of quantum computing.
Well, I wish we knew more about that, to be honest with you. If we had powerful quantum computers now, we'd be experimenting with them and trying to understand better what they do. As you know very well, Ken, in the case of the artificial intelligence technology that we're currently using, we really had to experiment to find out what it was capable of. And I think that's what we're going to do with quantum computers as well. We do think there will be applications to artificial intelligence. And to answer your question, I don't see any reason in principle why we couldn't have robots eventually that actually have quantum computers inside. There are a lot of practical problems we have to solve. But in the nearer term, I think your second scenario is the more likely one, that our robots will be communicating over the cloud with quantum computers. Now, as you suggested, one way to do that is to actually have quantum communication between the robot and the cloud, sending what we call quantum information back and forth. But that's more difficult. What's probably going to happen before that is we'll send ordinary information to the quantum computer, and it will be able to do faster certain computations that'll help the robot decide what to do next.
And I just want to say that artificial intelligence is not actually intelligent. If I put on the internet, look, I've got a way of how to play basketball or something, or football or whatever. Then if you ask AI, can you please help me with this and that, is how I can play basketball or I can play football, then it will say, here is a video, or I can give you these instructions. And it's basically stealing information.
Now we're getting very philosophical.
Absolutely. Kai, I want to differ with you a little bit on that, because I think it's true that it's trained on vast amounts of information. You're absolutely right. And most of that information comes from the internet. But what's very interesting about this new phenomenon of these large networks is that they do seem to be able to synthesize information in new ways. And they have the potential of coming up with new ideas. Many of us who are doing research will use them to bounce ideas as we would with a colleague. They haven't yet solved a major open problem, but they're making progress in interesting ways, and they can be steered basically with humans. So they can go beyond just repeating information that's already been published.
And with quantum computers, I guess we'll go even a step beyond that, right? So in terms of working with AI, that will be additional way of getting better solution and optimizing the best way forward.
It's really hard for any of us to predict what quantum computing is going to enable us to do. We do have reasons to think that for some purposes, it's more powerful than the way we're doing computation now, even with our big data centers. It'll be able to do some things that we can't do with a very large conventional data center, and we're aware of a few of those things. But the implications for artificial intelligence are an area that's actively being researched, but we can't make very firm promises about what quantum computing is going to enable us to do. But it is a different type of computation. I mean, one way of thinking about it is that when you're running a conventional computer, there's a sequence of steps, and each step along the way, what you're manipulating is just a long string of bits, where every bit is either a 0 or a 1 or an on and off switch. And with a quantum computer, the computation is sort of like a wave that goes through the network of gates that are being applied to the information. And what we want is for that wave to get focused on the right answer to some problem. And we know how to do that in some cases, but in a lot of cases, we haven't seen yet how that's going to work.
Another way that I think about it, John, is, and tell me if I'm wrong, but I think about just the ability to do parallel processing. So in other words, if you have one very fast computer, if you can extend this to quantum, it would be as if you have hundreds or thousands of very fast computers all working in parallel. And so you can do very, very complex computations very rapidly. There are many advantages to that, both for learning, because the learning process for these networks currently is somewhat bottlenecked by the computation speeds. But I can give you another example in robotics. So in robotics, as we're talking about, we are very interested in simulating. We need to learn how to, let's say, manipulate an object to be able to pick things up. So Kai, imagine that you just want to pick up a pencil on the table. Now, what happens is you're going to reach your fingers over and you're going to move to pick up that pencil. But the pencil, usually what will happen is one of your fingers will make contact with the pencil before the other finger does. Can you imagine that?
Yeah, like I think it'll be super hard to pick up a pencil for a robot because it needs to go here, here would be a pencil.
Exactly. You got it. That's perfect. So imagine though that pencil is on a very slippery table. So as you start to reach for it and your fingers are very thin, think about chopsticks. What'll happen is that pencil will start to twist, right, and rotate in certain ways, right? And so you'll have to think about how to adjust to compensate for that, right? And the computation of that is there's many different outcomes, many different ways that that pencil can move. That is something where in a simulation, we will try to anticipate all of those potential outcomes. And right now, trying to do that accurately for more reasons I can go into, but have to do with the minute nuances of deformations and friction with the table, we are limited in how many different options we can explore. So having a quantum computer, and I'm excited when John thinks that will happen, but I think that he and his colleagues are making amazing progress that will allow us to do that kind of simulation computation much faster. And so that will then give us new data that we can use to train the robots. And right now that is a huge obstacle to making progress. We just don't have the compute power to do those kind of simulations at the resolution that we want.
I'd like to add a little nuance to what Ken said. We can think of a quantum computer as performing many different computations all at the same time. But it's not obvious how useful that is unless we can get all those computations to work together somehow. And that's what I was trying to convey with the metaphor of saying it's like a wave and we want it to focus on the right answer. If we just have each computation doing its thing and, we're not taking advantage of all that parallelism, all those computations at once, unless we know how to bring them together to help us get the answer that we're looking for.
And Ken, what you mentioned previously about potentially having a quantum computer inside a robot, and So, John, how do you see that happening? Because right now, of course, they are A, huge, B, they need to be cooled down, at least with superconducting qubits, so it's not, or manipulated with lasers in the case of trapped ions. So basically, how can you, in the future, make them smaller, I guess, and put them inside a robot?
Well, you don't necessarily need a very, very cold refrigerator. You do need something to be cold, but you can cool things with lasers, which you were suggesting. One of the technologies is to manipulate atoms with lasers, and that we can potentially scale down to a small device. For example, if the lasers are all semiconductor lasers, and we can use the laser light to hold on to the atoms. So if we being a little futuristic here, but I think that's the spirit of your question, that I don't see any reason in principle why we can't have a quantum computer operating in a room temperature environment that's very small and still quite powerful.
Cool. That's something to look forward to. Okay. Gonna have robots and quantum computers inside them. That'll be very cool. Kai
Ooh.
visited ETH lab here in Zurich, so he saw a real quantum computer.
Was that on Andreas Wallraff's lab that you
Yes,
visited?
exactly.
Yeah.
It's interesting because the original computers were very large also. Now we have them in our cell phone, right? So very interesting that in the course of Kai's lifetime, we'll see amazing progress on these kind of things. I think I'm very curious to watch what happens with robots. And Kai, let me ask you, what robot did you see in the lab?
He went to ANYbotics.
ANYbotics. Okay, great. I know that lab. Marcos Hutter. It's a fantastic. These are dogs that can stand up. Is that right?
Yes, and it also looks like this. And that is really somehow in a way cute and in a way scary.
But what was interesting, the researcher who showed the robot dog did talk about quantum computers a little bit, and Kai asked a question about the robot getting stuck and asking through the cloud how, quantum computer could help it wiggle itself out. So I'm wondering how far we are actually from that scenario becoming a reality.
Well, one thing I will tell you is that there's a lot of experimentation going on with self-driving cars, taxis, robo-taxis. And these are starting to appear in Los Angeles and San Francisco and other cities in the US and also in China. And what's interesting is these taxis there's no human driving them. They're zooming around the city streets. But they do call humans when they get stuck. So it turns out that there's a human standing by for every one of those cars. And the human comes in, just as you're saying, Kai, in this case where they do get stuck. And sometimes it can happen several times an hour. And the humans come in very quickly and give them instructions on how to get out of that situation. So this is another example of cloud robotics. And whether it's a human or someday a quantum computer at the other end of that, it's really going to be important, I believe, to have some way of getting help when the robot gets stuck. So you're right on target about that is going to be a fundamental issue because you're never going to eliminate that altogether.
So, Kai, do you think you'd rather have a robot dog or a real dog?
I would rather have my real dog now.
Or do you think someday you'll prefer to have a robot dog?
No.
Why not?
Nature is way better than a robot. Okay, yes, I can say that books are now having a phone or an iPad is way better than having a book, I could say. So that's upgraded.
You know, Kai, you're very wise beyond your years. I appreciate that. I think your insight is very profound. Let me ask you, what if you had both? What if you had a robot dog and a real dog? And what if the robot dog could take your dog on a walk?
A dog walking a dog. That's what I'm hearing now.
Yeah. I mean, well, here's an example. Imagine that your grandmother or somebody wants to have a dog and she can't get around that easily. And this is actually a fairly common issue. So people actually want someone else to walk their dog for them. Or maybe they're out of town or something. So imagine you have a robot dog that could walk your real dog. Isn't that something that could be useful?
Yeah, maybe. But there's one problem. I'm not sure that a dog happy with a robot dog, I'm sure that would help.
But that happens with two real dogs also.
Exactly. Dogs will have to get used to robots in the same way that humans will in the future. Do you think they would become friends and basically teach each other tricks and things like that?
Maybe, but there's this problem. Usually owners should be looking after their dogs and be happy with their dogs. But if they're robot dogs and they like the robot dogs, then they will go to the robot dog and then play with the robot dog instead of its normal dog right behind. So that would be a bit sad. The robot does not matter if you're with your own dog.
Well, now suppose there are two robot dogs. Do you think they would fight one another?
Two robot dogs, because robots, like in movies, they don't show any emotion, really. And since they cannot show like if they're happy or sad, then they'll just be both next to each other, robot dogs.
And you're getting into a very interesting topic there. Actually, a lot of researchers are looking at right now, Kai, which is how can a robot communicate with humans? And that how can it show what it's feeling or what it's thinking? That is a fundamental question. And humans seem to do this with a variety of things, facial expressions, really nuanced elements that are very subtle, that you pick up on the hundreds of muscles in someone's face, moves their face in very subtle ways, and their eye positions, even the size of your iris in your eye changes microscopically, and people seem to respond to that. It's very interesting. The whole subfield of robotics is human-robot interaction. How will we design robots that will be able to convey they're doing what they're thinking? So these two dogs will be able to get along, or your real dog and your robot dog will get along in the future. That's a nice research topic that many researchers are working on.
That's great. Well, thank you so much. I think we're getting to the end of the episode, and I just have two questions for our guests. John, obviously you're a theoretical physicist, but I'm sure you're also using robots as well. Perhaps you have, vacuum cleaner robot. I'm curious, what excites you when you think about the future, the near future, hopefully, when we do get to quantum advantage and robots will be somehow getting help from quantum computers? What is the most exciting factor for you?
Well, you just reminded me, I do have a robot vacuum cleaner, and what it's most useful for is vacuuming up the dog hair. And with a robot dog, then I won't need it. But what excites me the most? Something really surprising is going to happen that none of us expected. That's what would be most exciting when we start advancing quantum technology.
Great. And Ken, how about yourself?
Well, I love that you said that, John, and I agree with you. I have been surprised in my lifetime several times with major breakthroughs, and when they happen, it's wonderful if you know the field and you just something comes out of, surprises you. It happens many times in research, but sometimes there are really big surprises, and they are absolutely wonderful, and I hope to live to see a few more of them. I know, Kai, you're going to see many of them in your lifetime. So you're already preparing. And I think like having these kind of conversations is so impressive. I will tell you that one of the things is I also have a cat, and we have a robot litter box for the cat, and it is tremendous. It is really helpful, I can tell you, because I don't want to worry about the litter box, but this thing takes care of it perfectly. And it doesn't use AI. It's just a motor with a sensor. It uses what I call good old-fashioned engineering. So you can look it up online, but you can buy it. It's like a rotating box that has some very clever clutches in it. So there are a lot of interesting solutions out there to the problems that are facing us. And I am very excited. I think we're going to see many new breakthroughs, and I can't wait for the next one.
Great. Well, thank you so much, Ken and John, for joining us today. It's been a fantastic discussion, and I'm sure Kai learned a lot, and everybody else as well. And thank you also to the team at ANYbotics. It's been a wonderful visit.
Hey, Kai, when you're ready for college, get in touch with us, okay?
Thank you.
And thank you to our audience. Thank you, everyone, for joining us. Please don't forget to
click that subscribe button, beep, and click that like button, beep.
Thank you, and goodbye.
Well, thanks. It was fun.
Yeah, that was great.
Bye.